And then we will be having Hadoop distributed file system, where this is all of the data will be stored in HDFS in terms of file, and the data will be saved in block of 64 by default, or we can also change it into 128 megabyte in size, which is logical splitting of data. It is a technique to store data in distributed manner in order to compute fast. So we know that HDFS will perform best for large files. So why do we use HDFS? Because HDFS is a fault-tolerant file system, because it did the data replication, where it will avoid the loss of data. It will replicate the data, and it also stored into a distributed manner, so it is a horizontally scalable. So this is the HDFS physical architecture. So we have name node here, where in name node it will store the metadata, and then we have different data node, whereby each of these data node has the replication data across multiple machine here. And then from the data nodes here, right, from each of these data node, we also have the heartbeat, because from here we are going to know which data node that is still alive or die. So once the data node is died, okay, we know that the first data node is died. Since we got the data replication in another data node, so we can retrieve the data in another data node here. So that is why it is called as fault tolerant, because we did the data replication. Let us take a look on the key distributed processing framework, where we are going to do the processing or the data processing using the Mapreduce. In Mapreduce, it is a method of programming in a distributed data stored in HDFS. So we are going to take all of the data in HDFS here, and then we are going to process them into the Mapreduce framework. It can be written using any languages like Java, C++, Pipes, or Python, Ruby, and etc. And then it can also be applied to any type of data, whether it is in structured or in unstructured data. So one famous example of Mapreduce is using doing the word count. Before we proceed to take a look on the example of Mapreduce, let us just take a look at the Mapreduce logical architecture. And in Mapreduce, we are going to have three phases. One would be mapper, sort and shuffle, or shuffle and sort, and also reducer phase here. So there are three phases. Right, this is 1, this is 2, and this is 3. So input data from HDFS will be input into the mapper phase, and then the mapper output on local what they call it, file system will be input into shuffle and sort phase, and then after doing the shuffle and sort, it will do the reducer, and it will put the output data on HDFS back. So what is the responsibility of these two phases, these two what they call the important phases? Mapper will do the extraction of the data, will do the transformation of the data, will do the filter of the data, and will do the passing of the data as well. Then reducer, right? Reducer will do the statistical function. For example, it will do the adding function, it will do the subtract function, divide function, multiple function, or any other mathematical or statistical function. So Mapreduce is an embarrassing problem description, okay, where a single task can be divided into smaller tasks and recombined into a single output. So in map, what map does is divides a big task into smaller tasks to be processed on different units of machine. And then map function would be in key value pair. So if you still remember on the NoSQL data that we have learned, so we are going to store them into key value pair. So for example, in word count, word would be the key, and then value is the value of how many counts that is available in a document. Okay, so in word count, map function will count the words in each document by placing a document on the machine, and then the key would be word and the value would be the count. Next, on reduce phase, reduce function will recombine multiple small tasks to become a single result. So in word count case, reduce function would take the count of words found in each document and then it will total up to produce a total number of word counted. So this is how Mapreduce work. So we got different document here. So we have document 1. So we have here document 2 and document 3 as well. And then it will do the mapping, okay, where it will pass all of the words here. For example, this is word number 1, word number 2, word in green color, word in orange color, word in yellow color. So it will pass into its different value here, right? And then it will do the shuffling, whereby it will sort and shuffle to its own similar category. So for example, green here will be sort and shuffle into green categories. The orange here will be sort and shuffle into orange categories, and yellow here will be sort and shuffle into yellow categories. So this is where we do the aggregation function, or we do the statistical function, where we will do the addition. For example, we will add all of this green into here. Okay, and then only we will get the output. So this is the word count problem. For example, we have 4 documents here. This is a big data training. The objective for the training is something, blah, 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 blah. The requirement of the training is blah, 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 blah. And more requirement of the training is blah, 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 blah. Okay, so what Mapreduce is, it will split each word, this document into a word. So for example, it will split into key value pair. So key would be the word and value would be the count. So for example, here you got 1 for this, 1 word of this, is 1 word of is, 1 word of a, big data training, and so on here. And then it will do the sort and shuffle, whereby it will sort and it will shuffle and sort and combine and sort all of these word here from all of different document into one here, into one list here. Okay, and then it will do another document to take the value of a training and so on, and then it will do the list of the value. Then it will do the reducer, where it will combine or it will add up the value here. For example, this will get 2 value, is will get 4 values, and so on here. So that is why we do the map and reduce function. If you still wonder how does the map reduce function doing the distribution process, each of these gray box here will be distributed into different computers or different servers. So different computers will do different computation, and then all of these computers will be recombine the output again. So it will do a parallel processing here. So this first server or the first computer will do one calculation, and the second server will do another calculation, and then it will reduce into one output. So instead of doing one by one from having a longer time, when it does work in a parallel way, so it will save more time. So this is another example of word count. And this is another example of if you would like to sum square of even and odd and prime numbers. So for example, you got 1, 2, 3, 4 here. And then in order for you to get the sum of square with even, odd or prime, you have to square all of the numbers. And then you are going to do the mapper, okay, where square 1 would be odd, square 2 here would be even and prime, and then you will do the sort and shuffle here. You will sort and shuffle and recombine value with even and odd here, and then you will get the output. This is another example, okay, doing the sort and shuffle, doing the Mapreduce on the colors. Okay,